we need to rewrite the following function in vertex form. So I often use the squares to visualize. I've got my x squared. Now I have negative 8x, and just for a little representation, I'm going to use red tiles, if you will. Not very good ones, but there's 4 of them there. So I have negative 1, 2, 3, 4, and negative 1, 2, 3, 4. So there's negative 4 and negative 4, which makes negative 8x. Now I have 5 unit tiles, but I know I would need 16. So for a minute here, I'll draw in 4 tiles. And then other ones, there's 5. I know I need a total of 16 in here to complete the square, which is the process we do to create vertex form. Now, on the outside here, so I know if I need to finish this square, I will need to complete to 16. Well, I have 5 in there. So to get to 16, I'm not going to draw them, but I know I need to add 11 tiles. Now, if you add 11 little tiles in there, that would change your equation. So we write the minus 11 to keep it balanced and make it technically 0. We did nothing. If we gave $11 and took away $11, we really wouldn't have changed someone's bank account. So we look at our outside. This is an x length, and this is minus 4. And this is x, and this is minus 4. And if we were to FOIL that out, we'd get x squared minus 8x plus 16. But we know those 16 aren't really all there. We had to add fake 11, so we'll minus 11. So my final vertex form will be x minus 4 quantity squared. And that minus 11 there is what we're going to use. And again, that comes from the fact that if I had to add 11 to complete the square, I have to subtract 11 to keep that equation the same. Now, I also did another analysis on Desmos where I graphed this original and my vertex form. And by doing that, you'll see here x minus 4 quantity squared minus 11 and x squared minus 8x plus 5, they're the same exact graph. You can't see what would have been the black function and the red function at the same time because they are the same equation. So I know by checking on Desmos that I got it right. Now, does this function have a max or min? It may not be able to tell so much from the vertex equation, and again, this would still be f of x, but if we look at our original problem, remember this first term here, when it's a positive x squared, it means it's a happy parabola. It ends going in the upward direction. So that shape would, of course, have a min. And how can we tell? I won't type that, but you could write, it's a positive x squared, therefore it will open up, or the end is up, so we know that they both have to point upwards in our end behavior, and it makes a minimum there. The actual point of the max or min, and that's when we do vertex form. Remember, the reason we turn it into vertex form is so we can see that minimum very easily, and the min will be then at 4, negative 11. And there is those, that's how we got those coordinates. It's the opposite of this and the same of that. So our max or min would be at 4, negative 11. Now we can go back and check that on the graph that I had made on Desmos. If I zoom in down there, look at, we go over to about what would probably be 4 if I zoom in. Right. Go down that line of 4, there's my 4 and negative 11, so that does follow through. And I didn't even need to use the graph, I just checked it. What are the x-intercepts of this function? I'm not going to spend a lot of time on this one because x-intercepts, remember, are what make this be 0. You could guess what numbers you could plug in to make it be 0, but I can already tell you that. Remember, we try to factor first to find zeros, but this does not factor. So we would have to use, and I'll leave it to you, this could be a whole nother video in itself. This would be the quadratic formula. And my picture of that graph will validate that the quadratic formula would be necessary because when I look at where it crosses the x-axis, that is not a pretty coordinate. And even if I click on there and give you an actual 0, a decimal there, a decimal there. So we're not going to use the quadratic formula right now, but you could sing the song and find those x-intercepts. The y-intercept, the easiest way to find the y-intercept is actually just to use this standard form, and right there would be our y-intercept. So that would be at the coordinate 0, 5. Note how each type of form, whether factored or quadratic formula, or the standard form or the vertex form, give us all these things a little bit quicker if we have all those forms.